Assalamualaikum. So in this video, I will discuss the example 6.1. Okay, for the goodness of fit task, for the categorical data. Okay, so I go to the traditional way lah to record this video. Okay. Okay, so we have the market analyst wish to see whether consumer have any preference among 5 levels of the new fruit soda. So we are talking about the 5 level of the fruit soda. So a sample of 100 people provides the following data. So the type of level, it is qualitative lah or categorical data. Okay, so qualitative or the categorical data, and then we have more than 2 category. Okay, we have more than 2 category, and it is from similar population lah. The consumer here, okay, 100 people here, they are coming from similar population. Okay, so this condition, this data fits to the assumptions that we have lah. Okay, but actually no need to check the assumption 1 until the third one. I hope that you understand what assumptions that I'm talking about. Okay, refer to the first part of our video. Okay, so actually we don't have to check the assumption 1 until 3, but you have to know that the data that you have here is a qualitative data lah. At least you know that. Okay, no need, you don't need to write that the assumption is fulfilled, no. Okay, because for the learning purpose, we assume that all the assumption number 1 until 3, number 1 until 3 already fulfilled. Okay, but the assumption number 4 we have to check later. Okay, a sample of 100 people, so the 100 here, that's your N. Okay, so we have 5 category here. We have cherry, strawberry, orange, lime and grape. Is there enough evidence to reject the claim that, okay, the claim that there is no preference in the selection of the soda flavor? Okay, so the claim, so this is the claim, so this is your rationale. Okay, this is your rationale. Okay, so as I mentioned in the first video, or you can read from your slide, claim will be at your rationale, and also your rationale must be with a keyword no change, no different and no preference. So what we have here, no preference. So this is statement for your rationale. Okay, so is there enough evidence to reject the claim that there is no preference in the selection of the fruit soda? Okay, so we know that we have qualitative data and more than 2 category, then we need to see the preference in the selection data. We need to see the different, okay, the difference of the observed frequency here to the expected frequency. Then we have to apply the goodness of fit task. Okay, so we go step by step. Your step 1, rationale, the hypothesis. So there is no preference. Okay, so H1 contradict to that. So there is a preference in the selection of fruit soda flavors. Okay, so step 2, if you want to state, then this is your claim lah. Okay, okay, the question could be there is no change or there is no difference, okay, in the selection of the fruit soda. Okay, so there is no change or there is no different means that there is no preference here, means that there is no preference to select the flavor here. So each flavor have similar preference. That's what we meant here lah. Okay, okay, And the step 2 is to calculate the chi-square test. Okay, so before we calculate the chi-square test, you have to calculate the E, expected frequency. What you have here is an observed frequency, that's your OI. This is OI. Okay, so back to the slide. In order to calculate the E, you have to we use the formula NPI. So you have to know the probability here, okay, in order to calculate the E. So you can put here PI. Okay, so what is a probability here? Okay, so the probability here based on the distribution of your data. Okay, for the categorical data here, you can have 3 different conditions of distribution for the data. The first one, you might be given percentage. Okay, the second one, you might have the ratio, and the third one, we have the category only lah, the number of category. Okay, so if you have percentage, then use that percentage for your PI. Okay, so percentage divided by 100, then you get your PI. So PI is a probability. Okay, so as you know, probability it is between 0 to the 1 only lah. Okay, so the value that you have here must be less than 1 but greater than 0. If you have percentage that represent for each category, that's what we call it as that's what we call as a distribution of your data. So percentage that represent for each category, that's the distribution. Okay, or you have ratio that represent for each category, so use that ratio for your PI. Okay, so what ratio that you have, divide by summation of the ratio, then you get your PI. Okay, so let's say that we have ratio 45, 6, 5 and 10 here. So you can have here, so PI, sorry, you left something. This is, let's say 30. Okay, so means that PI for the cherry, it is 30 divided by summation of the ratio here, 30 plus 45 plus 6 plus 5 plus 10. Then you have 0.3125 for your probability here. Okay, percentage, we know that the summation of the percentage is a 100, so you just divide by 100. Okay, if there is no percentage, there is no ratio in your question, like this question, there is no percentage represent for each category, or there is no ratio represent for each category, then we just use the number of category to calculate the PI. So here the number of category we have 1, 2, 3, 4, 5. So 5. Okay, so cherry, the probability of the cherry is one of the category here. It is 1/5. Okay, or it is 0.2. The probability of the strawberry, one of the category, 1/5. Orange 1/5, and lime 1/5, grape 1/5. So it is similar. Okay, we have similar PI. So that's your PI. Okay, so we have PI for each category. Okay, so E and PI. So N is a sample size which is 100 here. So 100 multiplied with the PI, we get the E for each category. Okay, I here represent category lah. Okay, it is, so in this case your I 1, 2, 3, 4, 5, because we have 5 category, so means that here K equal to 5. Okay. Okay, so we calculate for the EI. So we put here your EI. Okay, the first one, okay, 100 times 1/5, you get 20. 20. So because of we have similar probability, so all is a 20. Okay, so cherry, strawberry, orange, lime, and grape 20. Okay, because we have similar probability. If you have different probability, then different. Okay, you will have different E. Okay, and then after you calculate the E, then we have to check the assumption 4. Okay, the 4 assumption, okay, your EI must be at least 5. If not, we have to modify the data here. Okay, so must be at least 5. So we have to check your E here greater than 5 or not, greater and equal to the 5 or not. So in this case, all the E greater than 5. So you can proceed to the chi-square. Okay, let's say that the E here less than 5. For example, I don't have pencil here. Okay, let's say that we have 4 here. So what to do? 4 less than 5. So what we do, we combine the category. So you combine strawberry with the orange. And all must be combined. Your O must be combined. Also PI must be combined and E must be combined. Okay, we combine with the next category. Okay, the row is combined with the next category. But if 4 is here, then we combine with the category before. So grape combined with lime. Let's say that this is happened, then the new table will be, okay, I will sketch the new table. It will be cherry, strawberry plus orange, and it will be lime plus grape. Your OI, okay, so 32, 28 plus 16, okay, 28 plus 16, you will get 44 here, and then 14 plus 10, 24. Everything must be combined. Okay, so EI, it is 20, 24, and 24. Okay, so you have to make sure all the E here greater than 5. Okay, if you still have, after you combine the two category here, the E still under 5, then combine with the next category. Okay, you can have until 2 category here. 1, it will be impossible lah. You can have until 2 category. So it is okay to have 2 category here. The new category here, it is okay to have 2. Okay, the assumptions that category must be greater than 2, it is for the original data here. Okay, so if you combine your category, then the new K equal to 3. So the next step or the rest of the analysis, we have to use the new K and also the new table here, if you need to combine the category. Okay, if not, okay, for this case, the original one, all 20, then no need to do anything. You just proceed to the chi-square. Okay, because all the E here greater than 5. So means that before you calculate for the chi-square here, you have to make sure all the E greater than 5. Then you can proceed. If not, you have to do like this lah. You have to modify your data. Okay, remember that when we combine the category, all must be combined. Your O must be combined, your E must be combined, and also P also must be combined. Okay. Okay, so back to the original, all the E greater than 5, then we proceed to the chi-square. So how do we calculate for the chi-square? Okay. First category, cherry, so we have O 32, we have E 20, and then square divided by its E. Plus second category, 28 minus 20 here, square divided by 20, plus 16 minus 20 for the orange, and then the line 14, 20 square, 20 plus 10 minus 20 square, 20. Okay, so remember that chi-square is a positive distribution, so you have to make sure the chi-square that you get here is a positive value. Okay, sometimes if you forget the square here, you will get negative. For example, this one, 40 minus 20, it will be negative 6. Okay, so be careful. If you get negative, must be something wrong somewhere, because chi-square cannot be negative value. It will be always positive. Okay, so okay, so you will have here 18. So I just follow the solution in the slide. Okay, but you can calculate by your own. Okay, so in the slide we have 18, 0, 0, 0. Okay, you can calculate by your own. Here I just follow the solution in slide. Okay, I forgot to check. Okay, the number 3 here, it is your critical value. So in the first slide, in the first video already state that it will be always right task. Okay, so chi-square, so the alpha here 0.05. okay, so 0.05, and k minus 1, so k equal to 5 minus 1, 4. So you will get 94877. Okay, okay, step 4, decision. Okay, so your chi-square test equal to 18. If we plot in this figure at 18, it is bigger than 94877, so it should be somewhere here. So okay, so your chi-square test, it is in rejection region, then reject null. So chi-square test greater than critical value, so reject null. Okay, so step 5, conclusion. As I mentioned, for the conclusion here, you can write the statement, which statement that you support. So reject null means that we say no to the null, so we accept, we support the H1. So you can write statement of H1 at your conclusion. So at alpha 0.05, there is a reference, okay, in the selection of fruit soda flavors. Okay, so again, when we write the conclusion, alpha is very important to state, compulsory to state, because different alpha we could get different critical value, and decision might be different. Okay, so this conclusion only applicable for this alpha. Okay, so if the next question asks you the data here is a good fit or not, so here reject null means that observed frequency very different to the expected frequency, means that they are far to each other, so not a good fit data. Okay, so I think that's all for this video. I do hope that you can use this example to discuss your or to solve your exercise. If anything, you can ask me or you can ask your lecturer. Okay, so thank you.